Today's lesson is over 6.3, which is titled Slope and Rate of Change. The main idea of this section is to identify rate of change and slope using both tables and graphs. Our vocabulary today is both rate of change and slope, having that they're both in the main idea. And rate of change is something that describes how one quantity changes in relation to another. Just like rate was a ratio comparing two different quantities to each other, rate of change is very similar. Slope is the change in y values over the change in x values. So we want to think about this as rise over run. So our first example here is the table shows the number of miles a canoe was paddled on a trip. Use the information to find the approximate rate of change. So we have distance on top here as miles and time in days. And as we notice on the bottom here, our days, each jump we're going only one. So this is something to notice. Just like our sequences, we notice our change on the bottom here is 1. And typically, when we are looking for the rate of change, time is typically on the bottom because time is usually going to be our x value while distance is going to be our y value. So remember, as we said, it was the rise over run, and rise is going to be our y, run is going to be our x. So we want miles on top here. So just like we did on the bottom here, we see our changing a 1 for each one. We also see we're changing positive 20 for each jump up top here. So how we would do this mathematically is we're going to compare one set of coordinates. We'll start with the set of coordinates 240, because as I said, time is our x value, 220 and 1. So we're going to compare 240, here's our points, and 1 and 20. Said it the wrong way. So to do our change in x over change in y, we have to compare one y point to the other, the difference between them, and doing the same order with our x. We're comparing the second x point to the first. So we're going to label this first point as x2, y2 up top here, and this one is x1, y1, because then it'll work out a little better, then we'll get positive answers. Because then we'll have, on the bottom here, we have 2 minus 1, because again, this was our x2, this is our x1. The top has to follow just the same way. So since we started with x2, we have to start with y2. So then we have 40 minus 20. This is our y1. So 40 minus 20 is 20. 2 minus 1 is 1. So our rate of change is 20, and then don't forget our labels. We have 20 miles over 1 day. And that's another note, that our rate of change is typically going to be shown in the unit rate form. So we already have 20 to 1 here. So we have 20 miles per day. And that is our answer. We didn't even need to approximate there, as it was an exact answer. Example 2 says the table shows the number of miles a car drove on a trip. Use the information to find the rate of change. So, as we did before, we compared two of these points to each other using our x and y values. Again, fuel, when we're looking at this table here, we have miles and then we have gallons. So I'm already thinking our label is going to be miles per gallon, because typically gallon is our denominator rate. Dollars per gallon, miles per gallon, both of those are pretty common. So we know that's what we're going to be looking for here. So again, fuel is going to be our x value, distance is going to be our y value. And again, glancing at our chart, we see 3, 6, 9, 12, so this one actually goes up nicely. See, we have a +3 jump between 3 and 6. We're going to have a +3 jump between 6 and 9. as well as the +3 jump between 9 and 12. We do not need to use the two lowest values as I did in the last problem. It just worked out well for us. So to mix it up, we're going to compare here our 9 with our 3. So our point is, again, we have to remember our point is 339, and that'll be our x1, y1. And then our other point is 9, 117, and this will be our x2, y2. Again, I know I'm showing a little more work than I need to, but I do want to see on homework this set right here. So it's kind of good to put a star by it that we want to see which 2 points you're comparing. So now I can set it up into my formula here, because we want to put our x1 on the bottom, sorry, x2 first on the bottom, minus x1. Then following suit, we do our y2 minus y1. So now I have 117 minus 39 over 9 minus 3. So now I have to simplify. 9 minus 3 is 6, and 117 minus 39 is going to give us 78. Or we could use a calculator on that as well. So now I have 78 divided by 6. And again, we could use our calculator here. I'm just going to write MI and gallon on the bottom, so I can still remember I'm looking at miles per gallon. And since 78 is divisible by 2 and 3, 7 plus 8 equals 15. 15 is divisible by 3. 6 itself is 3 times 2. So we can divide both of these by 6 to get 78 divided by 6 is going to give us 1 goes into 6 goes into 7 once, and then I have 1 left over. 18 divided by 6 is 3, so I got 13. 6 divided by 6 is 1. So really I'm got 13 miles per gallon. So I'm just going to rewrite that up here as 13, and you can even shorten that as mpg for mile per gallon. And so that is our rate of change. Example 3 is a table shows the number of inches a child grew. Use the information to find the rate of change. So again, just like the last one, we're doing change in y over change in x. So we'll write that down quick. Change in y over change in x. And so we're just going to grab 2 points. So I'll grab 614 and 436. Typically it is better to grab the points toward the top, because then you're going to have the small rate of change. But between 4 and 6, I noticed a change of 2. Between these two numbers, 36 and 41, I noticed a change of 5. So my point 641 is going to be 641, and then I'm going to have 436. Again, notice how I did it so that all my values are going to stay positive. So 41 minus 36, I already wrote on the right side that that was 5. And again, these are inches per year, times typically on the bottom. So inches per year. 6 minus 4 is 2. So now I just have 5 halves that I'm going to simplify. We can take 2 groups of 2 from the top, because our denominator is 2. So 2 times our denominator gives us 4. So we can take 2 wholes away and we'll still have 1 half. So I have 2 and 1 half, and this is inches per year. So that's how much they're growing. 2.5 inches per year is our rate of change. So now we're moving on to graphs. As we said, we were going to be finding a rate of change from tables as well as graph. So the following graph represents the distance traveled flying in a plane. Use the graph to find the rate of change. You will notice that around this point my examples are going to follow Mr. Kratz's examples a little more closely. So I have my x values, again, are going left to right. X is across, so x is left to right. And distance is going up and down. So I have miles per hour. And that should sound very familiar to everyone. So Now I have to look at the points. They actually gave me the points in this one, so I can just use two of them. So we're going to call 2 600 as our kind of x2, y2. And then we're going to use our 1 300 as our x1, y1. Meaning that's going to be the part we're subtracting. So I have 2, and then I'm subtracting my 1. 600 on top, subtracting my 300. Because again, y's are on top, x's are on bottom. 2 minus 1 is giving me 1. 600 minus 300 is 300. Because I just use 6 minus 3 is 3, and the zeros follow. And so I have 300 over 1. And so now I'm going to rewrite that with our rate. Because again, top was mile, bottom was hour. So I have 300, and we can just write this mph for miles per hour is our rate of change. Next example is to use the graph to find the rate of change while driving on a highway in North Carolina. So our distance here again is miles, time is hours. So again, just a heads up, we know our label is going to be miles per hour. So it's good to keep that in mind. So now I'll take 2 points here. I'm actually going to take 3, 210, and 170. Again, I'm going to make this bigger one our x2, y2. I'm going to make the smaller one our x1, y1. Because again, we're subtracting the first set from the second. So 210 is going to be on top, subtracting 70. And then my x points are 3 minus 1. So 210 minus 70 is going to give me 140. 3 minus 1 gives me 2. And I still have to simplify because we want to find the unit rates, which is of course going to be the rate of change. 140 over 2 is going to give me 70 over 1, so I can just write 70 miles per hour. Now with that in mind, I look back at the graph. So I drove 70 miles in 1 hour is what that first point told us. This one says in 2 hours I drove 140 miles, in 3 hours I drove 210 miles. So that makes sense that we're going 70 miles, then 140 miles in 2 hours, and 210 in 3. It's kind of another way you can check it. Example 6 here says to graph the data, find the slope of the line, and explain what the slope represents. So, as you know, we kind of already have the graph here right on our right. It says 3 hours, and the amount earned is $45. So at this point here, we would normally find a graph on our paper, or we'd probably make an adjustment because I don't think most people have 45 lines on there, but we have 345 as the point. So we can tell we went 3 over, 45 up. Then our next point is 690 here. So we're on the 90 line and we are on the 6th. So the second point is 690. And the last point looks like it's 135. And that's also what the graph tells us. So we're going to plug in our first two sets. The 690 will be our x2, y2. The other one will be our x1, y1. So I have 6 minus 3 for my x values. And then I have 90 minus 45. And again, this was dollars per hour. Should have mentioned because we have our y value over our x label. Sorry, our y label over our x label. 90 minus 45 is going to give me 45, because 45 is exactly half of 90. 6 minus 3 is going to give me 3. And so now I need to simplify. You can use a calculator for this. 45 divided by 3 is going to give me 15 over 1. And then I have dollars per hour. So I'm going to rewrite this up top here to explain it. So we have $15 per hour, which means we are earning $15 per hour. Oh, my 1 milled it in here. Rewrite that. So $15 per hour would be, for example, a rate of pay. If you got $15 per hour, I would say made or earned, right there, word earned, $15 per every hour. And that would be how you would explain it. Just kind of explain, what does that rate mean? What is it telling me? Example 7, the table shows the cost of renting a bicycle. Use the graph of the data to find the slope of the line and explain what the slope represents. So I have here, again, they give us the point. We should be able to graph these points on our own if we have 2, 8, 4, 16, and 6, 24. So we can find the points here. We've got 2 over, up, 2, and this is actually going by 4s, which if you actually have to graph on your own paper, I would recommend doing it that way, as you're not going to fit 36 points on your graph. So 2, 4, 6, again, then we have our 4 point up here, and our 6. So I'll label my points. I have 2, 8, 4, 16, and 6, 24. Again, I'm going to go with my bottom 2 points of 4, 16. And that's going to be my x2, y2. And again, 2, 8. We always want our lowest point as our x1, y1, because then we have positive values when we're subtracting, especially when the slope's going up like that. And since y was our first point, we have to match, since 4 was our first point, we have to match 16 as the first one to make sure we keep a correct answer. So now I have 16 minus 8 along the top is going to give me 8, and 4 minus 2 is going to give me 2. And in this case, remember, we have cost, which is actually in dollars per hour, because we're talking about the cost of renting a bicycle. So this is dollars per hour. And we're not done, as we have 8 over 2, and we're trying to find a denominator of 1. So dividing both of those by 2, 8 divided by 2 is going to give us 4. 2 divided by 2 will give us 1. So we have $8 per hour. And again, $4 per hour. 8 divided by 2 is 4. So as you can tell then, for our slope here, we're going up for every 2 hours, we're going up 8. Is what this original part told us. So for every 1 hour, we're going up 4. And so that kind of explains what the slope represents. Again, I also recommend explaining $4 per hour mean it costs $4, right down here, $4 per hour to rent the bicycle, rent a bike. We're getting up to our last example here. Example 8, the table shows the distance for the distance y Chris traveled in X minutes while competing in the Boston Marathon. Graph the data and then find the slope of the line. Explain what it means. So here I've got time in minutes over distance in miles. So reading our question here, it wants X minutes and y distance, so y miles. So meaning we want miles per minute. Now just looking at our chart here, so then we actually have our x on top, does look like we're going to have a lot more minutes than miles. Because if you think about it, for a human running like a 6-minute mile, or 5-minute mile, 4-minute mile are all extremely decent miles. So that gives us more minutes than it does miles. So again, we're going to take 2 points, and in this case we're actually going to take our 20 and our 10, because that will work out pretty well. So my 2 points are 2096 being 0.2. Let's call that 0.2, or x2, y2, and then our x1, y1 is going to be, I mixed up my values here. Because remember, we're going miles, so I need to correct that. Instead of 2096, we're actually dealing with 9620. Right? Because x's are on bottom, y's are on top. So our 20 is going to be on top, minus 10. Then we had 20 on top, minus 10. So then we have to have 96 on bottom, minus 48. 20 minus 10 will give us 10. 96 minus 48 is exactly, 48 is half of 96, or you could use your calculator on that one. So I got 10 over 48. So on the bottom here, again, we've got to remember this is minutes, tops is miles, MI for miles, MIN for minutes. So we do want to find the unit rate. So we're going to have to divide each one by 48. Because we want 1 minute, and we're going to get a fraction of the mile. So we're going to bring out our calculator here, put in 10 divided by 48. And in this case, we're going to round to the nearest hundredth. So I have 0.208, and that's as far as I'll go. So I got 0.208. And I only go that far because I want to use this 8 to round up or down. 8 is bigger than 5. So we're going to round up. So our answer in the end is going to be, we have to switch our equal sign to approximate because we rounded. It's going to be 0.21 miles per minute. And that again ends our class for today in terms of the video. Again, remember we have the online tutors as well as the helper, homework helper online for all the work for the odd answers.